3, part 2 today. So this is going to be a review of what was done yesterday. So if you watched yesterday's video, we're in class. This shouldn't be a lot of new things. We're adding and subtracting fractions. In order to add and subtract fractions, you have to have the same denominator. So if we look at the first one here, the denominator has a 5x squared for both the left and the right side. So because there's a plus sign in between, all we have to do is add the 3x and the 7x together, and we get 10x from that. And then we keep the bottom the same because it has the same denominator already. And then just like any other time that we have a fraction, we try to simplify the fraction if we can. 10 divided by 5 is 2 over 1. And then there's one more x in the bottom. So in the end, this would just be 2 over x as our final answer. So that one's an easy one. Number 2 is a little bit tougher. It has a 2 and a 15. So the first thing I would do is find the lowest common multiple between 2 and 15. I believe if you multiply out 2, 4, 6, 8, 10, it keeps going all the way to 30. And then 15 goes 15, 30, 45, 60. So it looks like 30 is the first number that they both have in common. So the thing that I would multiply by on the left would be a 15. The thing I'd multiply on the right, oopsie, didn't mean to do that, would be a 2. And what you multiply by the bottom, you have to multiply by the top. So that will get you a 30 for both the bottoms, but they still wouldn't be the same. One has an a to the fourth, the other one has an a squared. So the biggest number of a's I see is an a to the fourth. So I wouldn't do anything to the left side because it already has the biggest number, but the right side is missing a to the fourth. So I need to multiply by 2 more a's. And when I do that, now I have the same bottoms. So if we took a look at this as one fraction or 2 separate fractions though with the same bottoms, this is what it looks like now. So they both have a 38 to the fourth. That means that I can subtract the tops or put it into one single fraction, however you want to look at it. So if we were to subtract the tops, they're actually not subtractable because they're not like terms. But I can write it all over one term. So now it becomes one single fraction. I can try to factor and then see if something simplifies from the top and bottom. So if we were to factor the top, I think we can pull out the biggest number as a GCF. Is that a 3? I think we can pull out a 3 and we can pull out an a squared. So now what's left over would be a 5a and then a minus 6. On the bottom, I have this 30 a to the fourth. So I look to see, can I simplify the 2 single terms, which are my monomials on the left side of the top and the bottom. So 3 divided by 30 can simplify. A squared over a to the fourth can simplify. So in the end, I'm going to have an actual simplified answer. 3 divided by 30 is 1 over 10. 2 a's cancel, so I'm left with a squared. So in the end, I just have a 5a minus 6 up top. On the bottom, I have a 10a to the second power. And that would be your answer. So that one, you had to find the LCD, make it one fraction, and then simplify that single fraction by factoring. The next one doesn't look so tough here. 3 and 4 would be our multiples that we're going to try to find a common number. And it looks like if you multiply by 1, 2, 3, 4, you get 12 to be the number that they both have in common. So that's definitely part of my LCD. And the biggest x I see is an x squared. So it must be 12x squared as my LCD. So we got to make sure that both the bottoms equal 12x squared somehow. So the left side I'd multiply by 3. The right side I'd multiply by 4x to get them to both be a 12x squared. So if you did this, you end up with 9x for the top left. The right side would be a plus and then a 16x. Those can both be over this 12x squared. So we can make it one fraction now. If we add the tops together, which they can add together, that gives me 25x. And the bottom is a 12x squared. I try to simplify that as much as I can. I think just an x can cancel. So it'll be 25 over 12x, because 1x I can cancel from the top and the bottom. That'd be it on that one, because nothing can go into 25 and 12. Yeah. All right. The next one has a trinomial on the bottom. Since the trinomial is identical on the bottoms for the bottom left and the bottom right, the only thing I would do is subtract the top right from the top left. So there's a minus sign in front of this whole right here. Here's the minus sign. So I'm just going to distribute the minus sign in front of that whole trinomial on the right side. So if I distribute a negative in, that'd be negative 3x squared plus 12x plus 2. So if I combine like terms, that'd be 7x squared plus 36x plus 5. And that's over 7x squared plus 15x plus 2. So then the last thing that you always try to do is see if you can factor and cancel anything. So I wonder if this is factorable or not. So the top is 7x and a 1x for sure. The bottom's a 7x and a 1x for sure, because those are the only multiples of 7. Multiples of 5 would be 5 and 1 and 1 and 5. So this 7 times 5 is 35. 1 times 1 is 1. So that'd be 36. So that one looks good. 15 would be 2. Oopsie. Would be 2 over here and 1. So that's 14 and 1. So it does look like something cancels because we just have the same binomial twice. So those cancel, and I'm left with x plus 5 over x plus 2. You can't cancel out those x's. Don't think about it. They're pieces of binomials. You can't cancel a piece of a binomial with another piece of a binomial. They have to be identical. So that is how you attack the ones with the same exact denominators. Again, with the minus sign. 5. These do not have the same denominator. So we got to factor first to see what we'd have for my LCD. It's going to always be my binomials I see on the bottom. What do we got on the bottom left? I think it's just 1 and 1. That's the only thing that gives me a 1. And that does give me 3 in the end. And then on the bottom right, I need a negative 1. So I think that gives me negative 1 in the middle if I multiply that out by FOIL. 2 times negative. Yeah, that's good. So the things I see on the bottom are 2x plus 1, an x plus 1, and an x minus 1. Those are the 3 different binomials I see. So you got to represent each one time. So the left side is missing the x minus 1. So that's what I'm going to multiply by on the top and the bottom. The right side is missing an x plus 1. So that's what I'm going to multiply by the top and the bottom. So now the denominators are identical. So that means you can multiply the tops out. Minus x plus 1 with a negative sign. This would give me x squared plus x plus 1. So now if I combine like terms, that gives me x squared minus 2x plus 1. The right side is negative x squared. Both of those would become a negative x, so there's 2 of them, and a minus 1. So if we combine everything, it looks like the x squareds cancel, and I'm left with a negative 4x, and the 1's cancel. So I think this would be it over my LCD, x minus 1, x plus 1, and there's a 2x plus 1. I can't cancel anything because the top's a monomial. The bottoms are all binomials. You can't cancel a binomial with monomials. So that's your final answer. All right, let's do one more, and we'll call it a day here. All right, 6. 6, I see that this is out of order on the bottom left. It's supposed to be variable first, constant last. So if I write it in order, I get negative x plus 7. And I know that I can pull out a negative 1 as my GCF. So I can move that negative 1 up now, because a 10 divided by negative 1 is negative 10. I always try to move the negative ones up. I think it makes everything easier for when we're looking for my LCD. So this is what we'd really have now. So we moved the negative 1 up, made that 10 a negative 10. Now the bottoms are identical. So the bottoms are the same. That means I can add the tops. I think that's going to be an easy one. That's just negative 2 over x minus 7. And that's all I got. All right, the rest you're on your own for. Hopefully you guys understood those pieces, and we'll see you guys next time.